Hello and welcome everybody to the Kreatryx YouTube channel and myself Ankit Goyal here in front of you presenting a lecture on analog electronics. So guys, soon you will be watching one of the best lectures on analog electronics, but before doing that, let me first introduce myself, my dear friends. My name is Ankit Goyal. I got AIR1 twice in GATE in 2014 and 2018. I was awarded the President of India Gold Medal in the year 2013 when I graduated from IIT Indore. Till date, I have taught more than 1 lakh students in the online and the offline classes, and presently I am working as a director at Unacademy for GATE department. But the reason, my friend, the reason for this series is because many students were asking for analog electronics, and I had recorded analog electronics just a short while ago. But due to that huge demand, we are giving you the recorded content of the analog electronics, and you are absolutely going to love it because it will provide you an in-depth analysis of analog electronics. And that analysis will be more based on network analysis than EDC. So if you don't have a prior knowledge of EDC, that is not at all required. When I am teaching analog electronics, I will be relating it more towards the network analysis. So you need to have a good basic understanding of network analysis so that you can do well in analog electronics. And my dear friend, what I believe is after this lecture series is over, your fear of analog electronics will definitely go away, and it will seem to be one of the easiest subject ever, because you will be applying the fundamental laws and you will be finding all the answers. Okay, so it will become very easy even for an electrical engineer, because I believe electrical engineers think of analog electronics as a nightmare. They are more comfortable in machines, power system, but not in analog. But now this analog electronics course will stand you at par with the ECE engineers, and you will be able to do well in analog electronics, and I believe you can get 100% marks in analog in GATE and ESE through this course. Okay, so my dear friend, you need to watch all these videos carefully. You need to understand each and every point, and they will also have a large number of questions, so your problem solving ability will be developed. And now my dear friends, you can also join us on Unacademy Plus. With Unacademy Plus, what is the benefit if I am teaching here on YouTube itself? My dear friend, GATE rank or ESE rank is not only about the lectures. First thing you have to understand that when you come to Unacademy, the level of teaching, the level of interaction, discussion is way higher than it can ever be done on YouTube. Because there we are interacting live with the students, and you will feel that your teacher is sitting right in front of you and teaching you on a one-to-one basis. So that sort of a feeling you will get on Plus. You will feel like somebody is taking a tuition class when he is teaching on Plus. That level of personalization is there. But not only live classes, you also get recorded sessions. Whatever session you miss will be available in the recorded form. You get daily practice papers for practice. You get weekly tests to test your preparation level. You get test series, previous year question bank, short courses like crash course and rank improvement batch, and you also get doubt clearing by all the top educators. Now, when you get so many things in just one subscription, then I believe if you are serious enough to crack GATE and ESE, you can get the top rank in GATE and ESE. And you can also go for Iconic. Iconic is a superset of Plus subscription. It contains everything that is there in Plus, but many things that are there extra in Iconic, like a personal coach who will be guiding you on a one-to-one basis about the difficulties that you face, about your weaknesses, about the challenges that you might face, about the strategy part. Everything he will tell you in a one-to-one session. Then he will be seeing your test results and giving you a personalized test analysis about what are your weaknesses and how you can overcome them. Then every 2 weeks, there will be a study booster session in which you can ask your doubts, whatever problems you have, and they will be helping you clear them. That is again one-to-one. Other than that, you will also get personalized study material. Here you will get theory notes and you will get question banks. You will get interview guidance. Soon enough, interview guidance will also be added. So the student who is starting his journey right now and looking to crack GATE and ESE with the top rank, Iconic will be the best subscription for that. Stay with me till the end of the video and I'll tell you about the pricing of these subscription. And my dear friends, if you like the videos that we are putting on YouTube, we have created an entire repository at this link. bit.ly/gatelive. Here you will find all the PDFs of all the lectures and all the YouTube links. So here you will find the complete syllabus of GATE, electrical, EC and IN. You will find it arranged subject wise, chapter wise with lecture links and PDF. So this is better than any other paid course available in the market, and plus is even better than this. So you can understand, whatever everybody else is providing you paid courses, we are providing you such a course for free via YouTube. So go and visit this link and take the benefit of all the lectures that are available. Other than that, my friend, I have also created a repository of my free classes on Unacademy called as the special classes. You need to open this URL, download the Unacademy learning app, and you can attend all my free classes, live quizzes and test series. Yes, my dear friend, we are running a free test series as well. So once you download the Unacademy learning app without even paying a single rupee, you can watch all the free classes by all the top educators along with their free live quizzes. And every Sunday we are conducting a free test that also you can become a part of. And if you want to learn from me, then my entire content is available on this URL. You can just go and visit this URL and see subject by subject, chapter by chapter, whatever I have taught, that will be available on this link. So first link will provide you all the YouTube classes for free and their PDF, and the second link will provide you my special classes on Unacademy. So that much content we are providing for free. Go and watch it, and if you like it, I would suggest that you come to Plus and use the code AnkitEAC. Because my dear friend, with Ankit EAC, you will get an immediate 10% discount, as well as you will be connected to me and we can work together to get you the best GATE rank, just like I obtained in 2014 and 2018. So if you want my guidance, if you want the best guidance in this market, if you want the best educators, then you have to join Unacademy. And while joining Unacademy, apply the code AnkitEAC to get immediate discount over and above whatever Unacademy is providing. You will get 10% additional off. Okay, so now my dear friends, let's go and watch the lecture and let's learn something new that you might never ever have learned, and let's enjoy the beauty of analog electronics. And I'll meet you again after the video and I'll tell you about the plans and the pricing.
Hi guys, up to now we have seen the basics of semiconductor devices. That is, we have seen the nature of semiconductor, intrinsic and extrinsic semiconductor. In extrinsic semiconductor, I told you about the p-type and n-type materials. So we have got a fair idea, that is how electrons and holes are present inside semiconductor and how they take part in conduction. I also told to you about the diffusion and the drift type of current. Diffusion current is when the charge carriers flow from high concentration to low, and drift current is when the charge carriers move under the influence of electric field. Now from this lecture onwards, I'll be starting a new topic, that is the PN junction diode. So in this topic, what we'll do is, we'll first take a look at the basics of PN junction diode, and then we will move on to application of diode in order to generate diode circuits. Okay, the more important part from gate point of view is the application of diode to form circuits, but before going on to that, we must have a fair idea about how does a diode operates and what is the internal working of a diode. Now, up to now I have told you that p-type materials are those where we have group 3 impurity, this impurity was such as boron. Okay, in that case I told you that number of holes are greater than number of electrons, so that holes become majority carrier and electrons are minority carrier. From now on, these terms are very important to us, majority carrier and minority carrier. Similarly, I told you about n-type of material. In n-type of material, we have group 5 impurity, for which I showed you the case of phosphorus. In this case, number of electrons are greater than number of holes. So in this particular case, electrons are majority carrier, and holes are minority carrier. Okay. Now in a PN junction diode, what happens? Basically, we have two type of semiconductor material, that is P type and N type. This is suppose P type material, this is N type material, and they are both joined together, and this line or the boundary is called as junction, or specifically it is called as PN junction. So PN junction diode means it is a junction of P type and N type material, and it has two terminals. The terminal connected to P type material is called as anode, represented by A. The terminal connected to N type material is called as cathode, it is represented as K. Okay. So this is the basic representation of a PN junction diode using a P type and a N type material. Before going further, let us understand how this diode is fabricated or how this diode is constructed. So first of all, what do we do is, we take N plus material. Now what does this plus sign means? Plus means heavily doped. Heavily doped means that the doping concentration should be around 10 to the power 18 per centimeter cube. That is called as heavy doping. Okay. So we take a heavily doped N plus type of material. Okay, like this. This is N plus silicon. That is our first step. Then what do we do is, in the second one, we deposit P type material. On top of it, what do we do is, we deposit a P type of material. Okay, like this. Now, once we have made PN junction, we need the terminals. So to form the terminals, we deposit aluminium on both sides. Aluminium terminal we use in case of electronics. So we deposit aluminium like this. This shaded region represents aluminium. Okay. This terminal will be called as anode, and this will be called as cathode. Now the question arises in the mind, why did I deposit aluminium? Why did I not directly take the terminals from the P and the N type material? Why terminals are not directly taken? See, the contact area of terminal is very small. This is the contact area of terminal. It is very small. If this area is very small, the resistance of contact is high. So in order to reduce the resistance of contact, if you want to have low contact resistance, the area of contact should be high. To increase this area of contact, we deposit aluminium over the entire material. Okay. Because if this contact resistance is high, the voltage drop across this resistance IR would also be high. When current will flow through the diode, if the resistance is high, there will be large voltage drop. And if you want to have a smaller voltage drop, what you have to do? You have to increase the area of contact. To increase the area of contact, we deposit aluminium over the entire thing. That will increase the area. Now, let us understand how to form diode one other way. Okay. How can we form diode? One other method. So, in that method, we first take N plus substrate. Substrate means the material in which the entire device fabrication will be taking place. It is the entire material in which we will fabricate the device. So what I am doing is, I am taking a large chunk of N plus silicon. Okay. The next step what we will do is create P layer by doping. Earlier what we did is we deposited P material over N plus. Okay, I wrote deposit P type material. But now what I am doing is inside this N type I am creating P type. How can you create P type material from N type? Tell me. If you want to create P type from N type, what is there in P type? In P type, number of holes are more than electrons. Now already the material is N plus. If already the material is N plus, that means number of electrons are more. If you want to make it P type, you have to increase the number of holes. If you want to increase the number of holes, you have to have acceptor impurity. In order to increase the number of holes, we need to have acceptor impurity. So if we do doping by acceptor impurity, we can convert this material to P type. So a small region in this N plus silicon I have made P type by doping with group 3 elements, okay, such as boron. This much is fine. Now again we have to make contact. Before making contact, I'll deposit oxide layer. This white layer is SiO2. It is also called as oxide layer. Now what is the relevance of this oxide layer is, it is an insulator. Okay, it is an insulator. It does not let the current flow. Now this layer is slightly removed in this region. We remove the layer from this region. If we remove the layer from this region, it will become empty like this. Okay. Similarly, we will slightly remove from this region like this. Okay. So then what we are doing is deposit SiO2 layer, remove certain portion by process of etching. You don't have to understand this process of etching. It is in fabrication, not in analog electronics. Then what we do? Deposit aluminium. Why we have to deposit aluminium? In order to create contact or terminals. So here I will deposit aluminium. Wherever I have removed the layer, I will deposit aluminium. From here now I will create cathode and here will be anode. Okay. So we are not depositing the terminal on the entire device, but in small region around the P type and the N type material, and in rest of the material there is SiO2 layer. What does this SiO2 layer do? It insulates the material. Actually, whenever we talk about IC fabrication, what is IC? IC is integrated circuit. When we talk about integrated circuit, that means multiple circuits are fabricated on the same silicon wafer. If multiple circuits are fabricated on same silicon wafer, then there is risk that current might flow from one device to the other. So in order to avoid any such short circuiting, what you have to do? In order to avoid such short circuiting, you have to separate the devices by oxide layer so that there is insulation between the two devices. So even in integrated circuits, we deposit oxide layer between the two devices so that current cannot flow between the devices and current of a device is restricted within the device. Okay. So that is how we form a PN diode, but we simply represent PN diode using the diagram that I showed here. This is the general representation, but actually the diode does not look like this. The diode is a little bit different, but this is how we will show a diode. Okay. Now let us talk about the internal working of the diode by starting with depletion layer. See, first of all, what happens in a p-type material? We have acceptor impurity. Right? In a p-type material, we have acceptor impurities such as boron. This acceptor impurity has holes. Holes are considered to be positively charged. But overall, the material is electrically neutral. Let me show you how. In p-type material, I told you when you have boron atom, it has 3 outer electrons. These electrons form double bond with the adjacent silicon atoms like this. Okay. But here there is a hole. But this boron atom is neutral, right? Boron has neither lost an electron or gained an electron. That is why it is neutral. This much is fine. Why I am saying boron atom is neutral? Boron usually has 3 electrons. It is not that it has lost an electron. If boron had lost an electron, you will call it as B plus. But if it never had an extra electron, it is simply boron. So, if boron is an atom which is neutral, how will I show a p-type material? I will show like this. Negative ion with a hole. Negative ion with a hole. Negative hole. Negative hole. What does this representation mean? This representation means hole is positive charge. This is negative charge. So net charge is equal to 0. Because this atom or this molecule is also neutral, so we will say net charge is 0. That is why along with hole I will show a minus sign so that net is 0. Is it fine? So what does this minus sign indicate? Now boron atom has 7 electrons. Why 7? 3 are its own. 4 electrons are from the adjacent silicon atom. What does it needs? It needs 1 electron to complete the octet, and if it takes 1 electron, it will become B minus. So this negative ion indicates if boron or if acceptor accepts electron, it becomes negative charge. Is it fine? In general case, the boron atom is neutral. But if it tries to fill its hole by taking an electron, then it will become negatively charged. If it takes an electron, this is a hole plus electron is null. So if you say this is boron atom with a hole, if it takes an electron, the hole will go away, only ion will remain. It is boron ion. Are you getting my point? So indicating a negative charge along with a hole indicates that if you take an electron, then the material will become negatively charged and hole will be filled, so we will remove the hole. Similarly, in n-type material, we have donor impurity. If we have donor impurities such as phosphorus, then it has extra electron. If it has extra electron, then how we will show? We will show n-type material like this. Positive ion with electron. Why positive ion with electron? Because if it is donor and it donates an electron, then only positive ion will remain. Okay, and right now this is positive charge, this is negative charge. So what is net charge? Net charge is 0. Are you getting my point? So our representation of p-type material is a negatively charged ion with a hole, and representation of n-type material is a positively charged ion with an electron. The net charge is 0, so the charge on an ion represents the charge after it gains or it loses an electron. That is the charge after that. Now let us see what happens if we join two such materials, a p-type and n-type. Okay. So initially, without joining, what happens? I am telling you the point where we are just joining the material. Here it is p-type, suppose this is n-type. Okay. This point is actually mentioned as x equal to 0. This x equal to 0 is called as metallurgical junction. Now if you want to show the concentration of holes and electrons, okay, we always know that this is N plus heavily doped and this is simply P. Remember, plus sign always indicates heavily doped, no sign indicates moderately doped, minus sign indicates lightly doped. Okay, these are the signs that we generally use. 10 to the power 18, 10 to the power 14, and it will lie between these two. The units are per centimeter cube. This is the charge carrier density. Now in n-type material, electrons will have a concentration of Nd. This is x equal to 0. Okay. If electron concentration is Nd, or let me write in a better way, you will understand one terminology also here. I will write Nn0. Nn0 means thermal equilibrium concentration of electron on n side. Okay. This n represents n side. If Nn0 is Nd, what is Pn0? By mass action law, it is Ni square by Nd. But on the n-type material, electrons are always more than the holes. So this is holes Ni square by Nd. Are you getting my point? Pn0 means hole concentration on n side at thermal equilibrium. Nn0 electron concentration on n side at thermal equilibrium. Similarly, Pp0 hole concentration on p side, it is Na. What is Np0? Electron concentration on p side by mass action law, Ni square by Na. But we know n side is heavily doped and p side is moderately doped, which means Na will be less than Nd. So this is hole concentration Na. It is less than Nd. If it is less than Nd, electron concentration will be slightly higher, Ni square by Na. What I mean to say, if Na is less than Nd, Ni square by Na is greater than Ni square by Nd. So in the green I have shown electron concentration, in the blue I have shown hole concentration on both the sides. Okay. So remember, x equal to 0 is called as the metallurgical junction, and that is how electrons and holes are divided on both sides of the junction. Is it fine? Now, if I show atoms inside p-type and n-type material, inside p-type I will show like this: negative ion with a hole. Okay. In n-type I will show positive with an electron, like this. Now the donor impurity, this is the donor impurity, it tries to donate the electron. This is acceptor impurity, it tries to accept the electron. Now both their requirements are getting filled. One atom wants to donate its electron and there is other atom which wants to gain the electron. Okay, if both are placed together, if you place both together, what they will do? They will exchange their electrons. So donor impurity is present in the N region. It will donate its electron to the P region. Try and understand this concept. Let me draw first. I told you before donating electron or hole, the atoms are electrically neutral. Now see, these electrons will move here. Now the reason for their motion is this. Why are they moving? Are you able to identify? Can anyone tell me why they are moving? They are moving due to diffusion. I told you in the previous video that whenever the concentration is high on one side and low on the other side, charge carriers diffuse. Now see, on the N side, electron concentration is high. On the P side, electron concentration is low. Okay. If electron concentration is low on the P side and high on the N side, the electrons will try to move from N side to the P side. If electrons are moving from N side to the P side, then these atoms will lose their electrons and these atoms will gain the electron. If they accept an electron, they become negatively charged. If they lose an electron, they become positively charged. So that is what I have shown here, that this is the metallurgical junction. The atoms where I have only marked plus sign, these atoms, they have donated an electron and they have accepted electron. So if someone is donating, it is becoming positively charged, and the other one is accepting, it is becoming negatively charged. Now electric field is directed from positive charge to negative charge. Are you getting my point? This is the basic condition, that electric field is always from positively charged material to the negatively charged material. These two regions, they are neutral. Why they are neutral? Negative charge of ion is neutralized by hole, positive charge of ion is neutralized by electrons. So they are electrically neutral. Electric field will only exist in this region like this, from positive charge to the negative charge. Now, as I have told you here, the electrons are moving by diffusion. So, the thought that will come in my mind is all the electrons should come to the p side, or there should be balance between both the sides, right? If the concentration on both the sides become equal, then what will happen? There will be no diffusion. So, does that happen? I am asking you, I am saying that electrons move from n side to p side because more electrons are present on the n side and less electrons are present on the p side. So, till when the electrons will move, till when they will keep moving. So, the option that I am giving you is, will they keep moving until concentration of both sides become equal? The obvious answer in your mind would be yes. If they are moving due to unequal concentration, they should keep moving until the concentration become equal. But the answer is, it does not happen. Let us understand why it does not happen. See, this electric field is generated. Now this electric field, earlier electrons are moving like this. This is due to diffusion. Now this electric field is from n region to p region. If this electric field is from n region to p region, the force on electron, if this is the electric field, the force on electron will be on the opposite direction to the electric field, because force on negative charge is always in opposite direction to the electric field. Now electrons have a tendency to go from n region to p region, but electric field tries to take them from p side to n side. So electrons will only move until these two cases are balanced. When electrons are moving due to electric field, this is called as drift. When they are moving due to concentration gradient, it is called as diffusion. So I will say, electron will cross the junction until drift and diffusion balance each other. Is it fine? Until they balance each other, the electrons will go from n region to the p region. Is my point clear? Electrons started to move from n region to p region. Why? Because concentration of electrons was high in n region and less in p region. But then, due to charged ions, an electric field was created that was applying a force on electrons from p towards n region, and if that is happening, it will stop the electrons from moving. When the two forces balance out, there will be no more electrons moving. Now if you see in this region that I have marked by blue boundaries, there is no hole or electron. There are only charged ions. This region is called as depletion region. Why depletion region? Because this region is depleted of any charge carriers. That means it does not have any charge carriers, or the charge carriers are absent from the material, and that is the basic definition of depletion region. So depletion region is present near metallurgical junction and it is devoid of any charge carrier, whether holes or electrons. There are no charge carriers inside it. Now if I want to plot this electric field, if I want to know how this electric field is present, so one thing that I can tell you is, electric field is only present inside depletion region. Why I am saying this? Because net charge outside is 0. I told you here itself that these are neutral. Why they are neutral? Negative charge of ion is balanced by hole, positive charge of ion is balanced by electron. if they are neutral, the charge outside is 0, so electric field will also be 0. Why electric field will be 0? We know E dot ds is equal to charge enclosed. That is your Gauss law. If the charge is 0, there will be no electric field. Hence, where the electric field is present? Only inside depletion region. Okay. If it is only present inside depletion region, so if we want to plot it, we will plot electric field as 0 at the outside the depletion region. So let us plot the electric field. Now as you can see, electric field is directed from N region to P region. I told you that the junction is x equal to 0. This is P side and this is N side. P side is x less than 0. N side is x greater than 0. Since electric field is directed from N side to P side, we will say electric field is negative because it is directed in minus x direction. Now, if you go from N to P like this, the charge carriers are increasing or the charged ions are increasing, plus charge ions are increasing. So electric field will also increase, but it will be negative. Why it is negative? Because it is in minus x direction. But now if you see further, this positive charge is cancelled by negative charge. So net charge will reduce. If net charge reduces, electric field also reduces. And it again becomes 0. This point I call as x equal to minus xp. This point I call as x equal to xn. So this is xn. This is minus xp. So where does maximum electric field occur? Maximum electric field occurs at the metallurgical junction or x equal to 0. Are you getting my point? How I have plotted this electric field? When I am going from N region to P region, first of all the charge is increasing, but as soon as I enter P region, negative charge is coming, which is cancelling positive charge. If charge is getting cancelled, net charge is reducing. If net charge is reducing, electric field will also reduce. Is it fine? Now, the distance between xp and xn is called as depletion width. So this depletion width is xn minus xp. This is called as your depletion width. So in this case, what you have to remember, why is depletion region created? It is created because donor atoms are donating their electron and acceptor atom are accepting the electrons, and in such a case neither the electron nor the holes are left, and that creates a depletion layer. A depletion layer will only be created up to the point the diffusion and the drift phenomena cancel each other. Okay, and inside depletion layer maximum electric field occurs at metallurgical junction. Now let us talk about charge neutrality. So if you see depletion layer, I am only drawing depletion layer now, or let us draw the entire thing. One thing I want to show you. Okay, this is my metallurgical junction. Here we have negative charge. And here we have positive charge. Okay. Here there are negative charge with hole. I am not drawing too much. Positive charge with electron. Now I told you already this region is neutral. This region is also neutral. Now how are these negative and positive ions created? It is because that the acceptor impurity has accepted electrons from donor impurity. Are you getting my point? Since the acceptor impurity has taken electrons from donor, these ions are created. That means these ions should be equal in number, because if donor impurity, suppose donor impurity gives 10 electrons, then how many electrons will acceptor impurity take? Acceptor will take 10 electrons. So if 10 positive ions are created due to 10 electrons, 10 negative ions will be created. Is it fine? That means number of negative ions should be equal to number of positive ions, because both have created each other. In p-type material, we have doping as Na. In n-type material, we have doping as Nd. This Na and Nd both have unit per centimeter cube. But we are talking about ions. If we are talking about ions, then we have to take number of ions. Number of negative ions. Negative ions are in the P region. Concentration multiplied by volume. Positive ions are in N region. Concentration multiplied by volume. Now volume is how it is calculated, area into width. This area you have to take, cross sectional area. So area is A. What is this width? This width is XP. Nd, area remains same, but this width is Xn. So what condition we get? NaXP equal to NdXn. This is called as the charge neutrality condition in a diode. Okay, this is your charge neutrality condition. That means you can say N into X is constant, or you can say N increases, X decreases. That means higher doping reduces depletion width. Okay, if you increase the doping, the depletion width will reduce, and that condition is derived from the charge neutrality condition. Okay. Now in the previous section I derived electric field for you. I draw the graph of electric field. Now I want to know electric potential. If I know electric field, then I can also know electric potential. How to find delta V? Delta V is minus E dot dx. Okay. So electric field graph was like this. This is minus XP. This is Xn. Now if you do minus E dot dx, you will get potential. But to take that area minus E, you have to take minus E. 1 minute. If you have to take minus E, E is already negative. By taking minus E, it will become positive. E is negative, but here minus sign is already there, so it will become positive. So if you take area of E from here, area will go on increasing as we move forward. Okay, we have to take total area like this. Total area will go on increasing, and integration of triangle will be parabolic. So before this it will remain 0. From minus XP it will start to increase. It will go on increasing up to Xn. After Xn, electric field is again 0. So electric field is nothing but dV by dx. It is 0, which means voltage will be constant. So it will remain constant. Okay. If delta V is minus E dot dx, electric field is minus dV by dx. If it is 0, voltage will remain constant. So this potential difference between N-type and P-type material is called as VBI. VBI is called as built-in potential. Built-in potential means the potential developed within the PN junction, and this formula is given by KT by E ln NAND by Ni square. Now we know from basic of EMT that positive charge has tendency of going from higher voltage to lower voltage. What about negative charge? It has a tendency to go from lower voltage to higher voltage. That means positive charge will try to go from where? Positive charge will try to go from higher voltage to lower voltage. Positive charge means holes. And negative charge will try to go from lower voltage to higher voltage. Negative charge means electron. This is P type. This is N type. If electrons are going from P type to N type, in P type holes are majority, electrons are minority. In N type holes are minority, electrons are majority. So it means these two are minority carriers. Are you getting my point? That means due to this potential difference created, minority carriers can flow but not majority carriers. Is this point clear to you? What I am telling is the potential of N-type material is more than P-type. That is shown in the figure. If potential of N-type is more than P-type, electrons will try to go from P to N and holes will try to come from N to P, which means they are acting as minority carriers, because in P region electrons are minority, in N region holes are minority. After this much is clear, we will discuss how we operate a diode. Now biasing. What is this biasing? It is applying DC voltage to set operating point. This bias term will come multiple times in analog electronics, so be aware about it. Bias is applying DC voltage in order to set the operating point of a device. Okay. Now when we talk about forward bias, it means positive voltage is connected to anode and negative voltage is connected to cathode. So how we connect? Suppose this is our diode. Okay. If this is our diode, this is our P region and this is our N region, we will connect positive terminal of the battery to the P terminal or anode and negative terminal to the cathode. Okay, that is your voltage supply. Is it fine? Now due to battery, first of all I'll draw the depletion layer. Here we had negative ions. Here we had positive ions. I told you due to this positive and negative ions there is an internal electric field created from N region to P region. That is internal electric field. Now due to this battery, electric field will be from positive to negative terminal. This is our E external. This is due to this battery, because electric field is from positive to negative terminal. If this E external is greater than E internal, the net electric field will be from P side to N side. Okay, I told you this electric field prevents flow of holes and electrons. Why? See, here we have holes, here we have electrons. So holes will experience a force in the direction of electric field. So this will be the force on holes, and electrons will experience opposite. So this will be the force on electron. Okay, but if the net electric field is rightwards, it is E external minus E internal. What will be the direction of force on holes? Holes are positively charged. So this will be the direction of holes, that is from P towards N. What about electrons? Electrons flow opposite to electric field. So this will be the force on electrons from N to P. Okay. So if external electric field is able to overcome the internal electric field, holes will flow from P to N and electrons from N to P. Holes in the P region are majority carriers. Electrons in the N region are majority carriers. So these both are majority carriers. So if holes are going from P to N and electrons are going from N to P, so current is in the direction of holes. This is current due to holes. Current is opposite direction to electrons. So this is current of electrons. So what is net current? I holes plus I electron, or you can say IP plus IN. What will be the direction from P side to N side? So what we will say, current starts to flow. Are you getting my point? If the external field that you are applying is able to overcome the internal field which was stopping the electrons from flowing, electrons and holes from flowing, then they will start to flow, and electrons will flow from N to P, holes will flow from P to N. And since holes are going from P to N and electron from N to P, these are majority carrier. In terms of field, what I am telling, if E external is greater than E internal, then current flows. But if we want to talk about in terms of potential instead of electric field, what I'll say, if applied voltage is greater than the built-in voltage, because due to this internal field we derived the built-in voltage which was KT by E ln NA and D by Ni square. If it is greater than that, then current flows. Instead of comparing electric field, what I have compared is the voltages. So this is also called as the VBI is also called as the knee voltage or cut in voltage. That is the minimum voltage required for current flow. It is written as again V gamma. Now this V gamma is taken as 0.3 volt for germanium diode. It is taken as 0.7 volt for silicon diode. So what we say is, if the applied voltage is more than the cut-in voltage, the current flows. If it is less than the cut-in voltage, the current does not flow. So what I'll say, the diode current is 0 if diode voltage is less than cut-in voltage. It is greater than 0 if diode voltage is greater than cut-in voltage or V gamma. Okay. Now the equation for diode current is this. This is derived in electronic device, so I am directly writing the equation. Vd by eta Vt minus 1. Is is called as reverse saturation current. Vd voltage across diode. I will tell you the significance of reverse saturation current later. Vt is thermal voltage. Don't think of it as threshold voltage. It is thermal voltage. It is equal to Kt by E. Okay. It is also equal to 26 millivolt at 300 Kelvin. Okay. Eta is called as ideality factor. If not given, take it as 1. But usually eta is 1 for germanium and it is 2 for silicon. But if not given, take eta as 1. Okay, don't take it from your side only that eta will be 2. Now sometimes what happens is we approximate this equation. How do we approximate this equation? That if Vd is much greater than eta Vt, or generally we say if Vd is greater than 3 eta Vt, then this will be e to the power 3. E to the power 3 is very much high than 1. So we say we will ignore 1, is e to the power Vd by eta Vt. Okay, that will be the diode current if Vd is much greater than eta Vt, because 1 then can be ignored. Now let us understand the meaning of reverse bias. In reverse bias, what do we do is we connect negative terminal to anode and positive terminal to cathode. Okay, that is how the connections are made. So if I show you the connection, this is our diode. Suppose this is P-type material. This is N-type of material. We are connecting negative terminal to the negative terminal to the anode and positive terminal to the cathode. I will show the depletion layer also. Like this depletion layer will be present. Okay. Now I told that there is internal electric field like this, from positive charge to negative charge. Now due to this applied voltage, there will be external electric field. If there will be external electric field, it is again from positive to negative terminal, it is E external. Now if you see, the internal and external electric field are in the same direction. So the net electric field is E internal plus E external. If the net electric field is in this direction, the force on holes will be parallel to electric field. Force on electrons will be opposite to the electric field. Towards left means N to P. Towards right means P to N. If electrons are moving from P to N, in P, electrons are minority, holes are majority. In N, holes are minority and electrons are majority. So that means these two are minority carriers. Why minority? If you see, holes are moving from N to P. In N, holes are minority. So that means we are talking about minority charge carriers and not majority. So what happens when we apply forward bias? We are talking about majority carriers. Majority carriers means having high concentration. They are moving towards low concentration means we are talking about diffusion. Now here the charge carriers are moving due to electric field. That means drift. So you can say In forward bias, since majority carriers are flowing, we are talking about diffusion current. In reverse bias, since minority carriers are flowing, we are talking about drift current. Now, if you see here the atoms have holes like this. Here the atoms have electrons. Okay. Now if you say that electrons are experiencing force rightwards like this, holes are experiencing on left. That means holes will be removed from P region and electrons will be removed from N region. If you are removing holes and electrons, we are increasing the depletion width. If you take out these electrons, they will become a part of depletion layer. If you take out these holes, they will become a part of depletion layer. So what you can say, depletion width increases. Okay. Remember, in reverse bias, the depletion width increases due to removal of electrons and holes, and in forward bias, depletion width reduces. Okay. Now, in reverse bias, we know that diode voltage is negative. Just now I told you diode current equation Is e to the power Vd by eta Vt minus 1. The graph of exponential is somewhat like this. E to the power 0 is 1. That means for x less than 0, e to the power x is less than 1. So in negative region, this term will be less than 1, due to which diode current will be minus Is. Minus means from N side to P side. If you see here, if we want to see the current will due to holes. Current due to holes will be in the same direction as holes. Current due to electron will be opposite to electron. So the net current is IH plus IE, or you can say IP plus IN, and based on direction it is from N to P. So that is called as the reverse saturation current. That means when we apply reverse bias, a small amount of current flows through the diode from N region to P region, and the reason for this current is the flow of minority charge carriers. Is it understood? Now, this Is actually doubles for every 10 degree centigrade rise in temperature. Is doubles for 10 degree centigrade rise in temperature. Why? As I told in the previous lecture, as you increase the temperature, charge carriers increase, and by increasing charge carriers, the current increases. So what I say, Is2 is Is1 2 to the power T2 minus T1 by 10. Now if you see T2 minus T1, if T2 minus T1 is 10, Is2 is how much? 2 Is1. So that is what I am saying. For 10 degree centigrade rise in temperature, the current will double. Now based on this forward bias and reverse bias, what we can do is we can draw characteristics of the diode. So I told you in the forward biasing we can take the exponential term. This is V gamma, cut-in voltage. In forward biasing, it will exponentially increase after V gamma, and in reverse bias, it is constant at how much? Minus Is. Later on, we will see that there is a limit minus VR where it breaks down and current starts to increase. It is called as reverse breakdown. This we will see later on. Right now what I have told you is this is reverse bias, and this region is forward bias. Forward bias is when we apply positive voltage, reverse bias is when we apply negative voltage. So let me summarize what we have learnt. In this video, we have learnt about construction of diode. Then I told to you the concept of depletion region. In this I told you when depletion region is formed, electric field is only restricted to depletion layer or depletion region. E max occurs at x equal to 0. Then we derived built-in potential. It is kT by E ln Na Nd by Ni square. No need to remember this. This will not be included in numericals. Then we learnt about forward bias. I told you if internal electric field is cancelled in forward bias, majority charge carriers begin to flow. And the phenomena by which majority charge carriers flow is called as diffusion. Then we learnt about reverse bias. When we reverse bias diode, minority carriers flow and it is called as drift. Okay, so drift means due to electric field and this is due to concentration gradient. And we learnt about diode equation, diode current equation. Vd by eta Vt minus 1. Eta is the ideality factor, 1 for germanium, 2 for silicon, and Is is the reverse saturation current. I told you about temperature dependence of Is. That is like this. Okay, for every 10 degree centigrade rise in temperature, Is will double. Why is it increasing? Because by increasing temperature, charge carriers are increasing, which will increase the current flow. Okay, so remember this much. In this entire section, you have to remember the diode current equation and this temperature dependence, and that will be sufficient.
Hello everybody, how did you like the lecture? Did you like it or not? Did you enjoy the concepts or not? Tell me in the chat and the comment section. Did you guys like what you just saw? Did you guys understand each and everything, my dear friends? Okay, so if you liked it, then please share, please like the video, and please leave a comment behind, because your comments are very, very valuable to all of us, and we do read your each and every comment and we go through them to understand what are the difficulties you are facing and how we are performing on YouTube. And my dear friend, a bonanza for you. Every subject is available on this YouTube channel. You just need to scroll through the channel and you will find all the courses. EDC, EMT, COM, machine, power system, power electronics, network, signal control, digital, maths, Apr, everything is available here, everything. So you can just use this channel as your entire preparatory study material. Okay. Other than that, now all of you who wanted to know about the pricing of Plus, 1 year subscription on Plus will cost you 27,225 if you apply the code Ankit ESE. But now, my dear friend, there is a new subscription, 18-month subscription. Those of you who are starting your preparation mid-year can target GATE twice, or you can target GATE and ESE mains with 1.5 year subscription. That will cost you 34,650 if you apply the code Ankit ESE. If you see the difference, only 7,000 difference is there, but you are getting 6 months extra. And even better, you can go for 2 year. It will cost you 39,600. That is again in just 5,000 rupees, you are getting 6 months extra. So you can target all the exams like GATE, ESE, semester exams, ISRO, BARC, everything you can target with just one subscription. And if you go for Iconic, in which I told you about the personal coach, study material, interview guidance, for 12 months it will cost 4,500 if you use the code Ankit ESE, and for 24 months it will cost you 54,000 if you use the code Ankit ESE. Ankit ESE is your code, my code, our code, and that will give you an instant 10% discount over and above whatever Unacademy is offering you. And my dear friend, that will connect you to me so that we can work together towards getting the best GATE rank. So don't hesitate, join today, because winners always start early, winners never start late. So it's always better to start immediately rather than thinking about it and becoming late and later on regretting your decision. Believe me, you will not even regret one day when you join Plus. So it's high time that you join Unacademy Plus and get the best out of you and become the best version of yours. These are the other channels that we are running in other than Kreatryx. You will find Electrical Junction. Here you will find short videos for gate preparation, gate question for PYQ, GS Terminal for non-technical content of SSC and RRB, Pathshala to learn engineering through animation, SSC JE for your JE and AE exams, my dear friends. Other than that, Telugu, if you want to learn engineering or gate and ESC preparation in the Telugu language, if you are comfortable with it, go for Telugu. Other than that, we have separate channel for mechanical, civil, computer science. You will find all these channels. Please share these channels with your friends as well so that they can also get benefited in the same manner that you are getting benefit from our side. Okay. So thank you everybody. See you soon in the next video. Don't forget to like, share and subscribe. Share it among your college friends, among your Facebook, WhatsApp, Telegram, Instagram, everywhere you need to share it. And you need to subscribe to this channel, press that red button and hit the bell icon, because my dear friend, this channel is creating a revolution in the gate and ESC industry and you, my friend, are a part of this revolution. So see you soon. Thank you.